Okay, complementary angle theorem is basically cofunctions of complementary angles are equal. And so, for example, I'm going to tell you that the sine and cosine are considered cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are defined to be cofunctions. The other thing to remember from geometry is that complementary just means the angles add to 90 degrees. So 30 plus 60 equals 90, 40 plus 50 equals 90, 80 plus 10 equals 90. So that kind of gives you a little bit of an idea and some notes down here to just keep in mind in respect to this definition, to this theorem. Alright, so let's see how we can work a few examples using this. Okay, using the complementary angle theorem, we're going to work with the sine of 62 degrees. Okay, by the definition of that, what's the complement of sine? Cosine. And one way we can do the complement of that is just say 90 minus 62. That would allow us to find that other part, right? The other angle. 90 minus 62 would equal to what? Cosine of 28 degrees. Good. So basically, the calculation of this is going to equal the same calculation we would have for that. So, and this is just kind of like the show your work step. And the more you do this, you'll be able to go quickly from here to here. But I'm just going to go ahead and write that extra step in there for the sake of practice. If I give it to you in radian form, so pi over 12, tan of pi over 12, what's the cofunction for tangent? Cotangent, good. Alright, now, it gave it to me in pi, so what's the equivalent of 90 degrees but in radians? Pi over 2, absolutely, right? So pi over 2, and then I want to subtract out the pi 12s. Now, what are we going to need to do for this? With fractions, you need to go off to the side and get a common denominator and then simplify. So common denominator of a 12 here would just give us cotangent of, you should have simplified that to get 5 pi 12ths. Okay, let's try another one. Cosine of pi 4ths. What's the cofunction of cosine? Sine, good. And then we're still going to do pi halves because it's the equivalent of 90 degrees. Subtract out the pi 4ths. Once again, you'll do some scratch work to the side to get a common denominator and simplify. And then it should reduce to sine of pi 4ths. Okay, I'm going to let you try number 6 on your own. So if you'll pause it, I want you to give me work cosecant of pi 6th. And so I'm going to pause it and let you try this one. Okay, cofunction is secant. We'll take this pi halves, which is the equivalent of 90 degrees, subtract out the pi 6 to get secant of pi thirds. Okay, so use identities or complementary angle theorem to find exact values. Okay, so if that's all we have to evaluate, let's say we don't have a calculator or anything to get these actual values, then we're going to have to use some of our other tools. So the first thing I want to do is I'd like to be able to get everything in terms of either sine or cosine. I'm just going to start with the sine of 27 and leave it alone, and I'll work with changing this cosine. So I'm going to work with this one. What's using the complementary angle theorem, that can be rewritten as the sine of 90 minus 63 degrees, right? So if I just keep bringing this sine of 27 down for right now, what does the right hand side simplify to? Sine of 27 degrees. Well, what's sine of 27 minus the sine of 27? Even though we don't know that value, we do know that something minus itself is simply going to be what? 0, right? Okay, our next one, same directions, but we give cosine of 13 degrees over sine of 77 degrees. Now I have some options here. I can either work with this one or I can work with this one, but typically it's probably I would suggest working in the numerator if possible. So let's work with the cosine of 13 using the complementary angle theorem. So that one's going to be sine of 90 degrees minus 13 degrees. Whoops. Let me fix that. Okay. And then over the original denominator, so you choose one to work with and you try to make it similar format of the other one. So you have some options there. So what does 90 minus 13 equal? Sine of 77, which just gives us over the original denominator, and what will this simplify to? Just 1. Good. Okay, so number 9, we have 1 minus cosine squared of 41 degrees minus cosine squared of 49 degrees. So these are not like terms in the sense that it wouldn't be the same angle minus the same angle. So we're going to have to do some work here. Now, the fact that I see some squares going on and they told me identities, the first thing that comes to mind is to recall some of my Pythagorean identities. So we want to recall off to the side. The Pythagorean identity dealing with sine and cosine will be sine squared theta plus cosine squared theta equals 1, right? Remember that one? Now, if I wanted to replace one of these, then I need to solve that for using the cofunction. What's the cofunction of cosine? Sine. So if I need this to be solved in terms of sine, I would solve this for sine squared. Sine squared theta equals, so that means I'm moving this cosine squared theta to the other side, so it's just represented 1 minus cosine squared theta. So I just recall this information to the side. That's some previous work that we've done, and I'm going to replace this 1 minus cosine squared theta right here with sine squared of 41. Okay, so that's where we used an identity. Now I'm just going to continue to carry down my right hand side. To be able to simplify this without having a calculator, these have to have similar degrees. So what can I do with this sine squared of 41? What's the cofunction of that? Cosine, right? So if I showed all my work, it would be cosine of 90 minus 41 degrees. Let me keep my degrees careful there. Just keep bringing down my right hand side. Now, what will this simplify to? That simplifies to the cosine squared of 49, and then now we can see that what happens here. They subtract each other out and we'll just simplify to 0. Alright, tangent of 15 degrees minus cosine of 75 divided by cosine of 15. Now, we have identities or we have angle theorems to work with. The more complex side to work with is this looks a little bit more complicated, but we have more options to work with this. Tangent of theta, we're going to leave this one alone in this case and see if we can get this side to simplify in some kind of way to match tangent. So tangent of 15 degrees, let's just leave that alone. Now over here, what is tangent divided by? Let's just think ahead of the game where we're going. What's tangent? Sine over cosine. Well, this is not sine over cosine yet, but is there something I can do with this to make this sine over cosine? Yeah, so we can do our complementary angle theorem for that numerator, and let me just, I'll do it in a different color. So cosine of 75 is going to be equivalent to the sine of 90 degrees minus 75 degrees. Right there. Leave my denominator alone, because you have to start with the end in mind. Sine over cosine is tangent, so I'm hoping to get to that point. carry down tangent of 15. Okay, what does the numerator simplify to? Sine of 15 degrees. My denominator stays cosine of 15 degrees. I am really liking that these are the same degrees now because that means I can simplify sine over cosine to be what? Tangent of 15. Good. So I'll bring this down. And now this can be tangent of 15 degrees. And we will see that this is just going to simplify to 0.